Folks, Mr. Norma, we're going to go over how to recognize dilations and to write their equation. So first thing first, when we look at this is our parent function. How do we know that? We haven't moved away from the origin, the point's there. Here's the other way. We move to the right and we move up. So we go over one, up one. This point is on our graph. It also works going the other way, over one, up one. This point is on our graph. So this is our parent function. What is our parent function for this? Parent function is y equals x squared. It's quadratic. So let's look at this other function. We go over one, we go up one, it's not there. So we keep going. It's over, up one, up two. 1, 2. This is up 2. What is this like? This is like a vertical stretch. It's smaller than the parent function. What is a stretch? It's a whole number. So to write this equation, we have y equals 2, because it's a stretch. It goes in front. And then we're going to have our x squared, because it's our parent function. We didn't move left or right, so this is what we have. So how do we describe this in words? So if we describe in words, we have a vertical stretch by a factor of 2. And that's how you answer this. So I'm going to scroll down. So let's look at this one. Which one's our parent function? Let's see. We're going to go over one. We're going to go up one and up. There it is. That's our parent function. It didn't move on the origin. It's over one, up one. That's our parent function. What's the parent function equal? So it's f of x, which is the same thing as y equals the absolute value of x. So let's look at our not-so-parent function. We're going to start at the tip, and we're going to go over one. How much do we go up? So if this is a half, this is a half, this is under that. So I'm going to call that 1/3. So what is our equation? Well, it's f of x. We're going to go 1/3 because this is our, oh wait, this isn't a stretch. This is a fat fraction. What's a fat fraction? That's a compression. And what's our parent function? Absolute value of x. We didn't go left or right. And how do you describe this in words? We have a vertical compression by a factor of 1/3. So the other two are for you to do, not for Yao, for you. Remember the rules for transformations work the same if it's a quadratic or an absolute value function. So next we're going to go to another one of these. So we're going to look at another one of these. We have a little bit more movement going on. So which one's our parent function? The right one. How do we know? It's at the origin. We go over one, we go up one, and voila, it's there. So this is our parent function. So let's look at this one. Oh, look at this. We've gone up in the air. We're also flipped upside down. So if we're going to start our equation, it's flipped down, and we know we've gone up 1, 2, 3, 4. So plus 4 back here. So let's figure out what's happening in the middle. It's not shifted left or right, so it's just going to be x squared. Now we just need to find out what number's here. So if we start at our tip, we go over 1. How far do we go down? 1, 2. Notice we count from wherever this tip is down. So that's 1, 2 down. So what do we have here? This is a whole wheat whole number. So that makes it a stretch. What does the negative do? It's a reflection or a flip. And this is shift up 4. Or a translation up 4. And where does this come from? This comes from a parent function. So if we describe in words our transformation, it is a reflection across the x-axis with a vertical stretch of 4 and a vertical shift up 4. Oh, this is not a vertical stretch of 4. This is a vertical stretch of 2. So that's 1, 2, 3, 1, 2, 3 parts. On to our last example of dilation. Which one's a parent function? Yeah, it's pretty obvious. So we're going to look at this. So our parent function is y equals absolute value of x. Oh, you know what? Let's switch it up big time. G of x. It all works the same. So what do we have here? It moved over 1, 2, 3, 4 to the left. So it went 4 left. It went down 2. It's flipped. And it looks kind of fat. I think we have a fat fraction. And a fat fraction is a vertical compression. So let's make our formula. So we got, let's go y sub 1 equals. So we know it's negative. We know we have a minus 2. It's absolute value. We're going to have these bars, right? It's shifted, so we're going to have something inside. We're going to have x. Oh, let's make room for a number. So if it goes to the left, we put a plus. And it went to the left how many units? Quattro. So now we just have to look at our compression. So we're going to go over 1. How much do we go? Well, that's a half. So you have 1 half in front. Easy peasy lemon squeezy. The rest will be left up to you to finish an exercise. I'll have an assignment posted for you to do. Please make sure you write the description in words as well as the equation inside of your composition book and send me a picture. Thank you for participation. Cow folks out. Peace.